Okay, so before we go over logarithmic differentiation, we want to know what's the derivative of the natural log of x. Okay, so this is our question. So to actually find this, we're going to start off by using a property that we know. We know that e to the natural log of x is equal to x. This is one of the properties of logarithms that we know. So now take a look at this. If I get the derivative of both sides, the derivative of the left side and the derivative of the right side, well, notice that on this side, we would have to use the chain rule because we have a function of another function. So the derivative of this guy, remember, is, so from the chain rule, this guy right here, this is the inside, right? And this is the outside right here. So I get the derivative of the outside. The derivative of e raised to a power is just itself, so e to the natural log of x, times the derivative of the inside. But hey, I don't know the derivative of natural log of x. So what I'm going to do is I'm just going to write it as the derivative of natural log of x, symbolizing that I have to get the derivative of it from the chain rule, but I don't actually know what it is. Okay, and then this is going to equal to the derivative of x is simply the number 1. Okay, well, check this out. This guy right here, e to the natural log of x, that was my original starting point. This is simply equal to x. So then what I have is that x times the derivative of natural log of x is equal to 1. Well, all you have to do now to finish this party is divide both sides by x, and you get that the derivative of natural log of x is equal to 1 over x. And that's it. Okay, so let's do a couple of examples. Let's start off with, let's say we want to find the derivative of natural log of, how about x squared? Okay, so this guy, well, if I want to get the derivative of natural log of x squared, I'm going to have to use the chain rule. And so I've got this guy, which I'll call the inside, and then the outside function is the natural log function. So I get the derivative of the outside, which is simply 1 over x, but since I have x squared here by the chain rule, I'm going to leave the inside alone. So I leave the inside alone, and then times the derivative of the inside, which is simply 2x. And notice that this simplifies into 2 over x. Now you also might have noticed, I don't know if you thought of this or not, but if you take a look at this guy, by the laws of logarithms, you can bring the 2 out in front. This is the same as saying the derivative of 2 natural log of x. And notice that if you get the derivative of this guy, you would get also 2 over x. This one using the laws of logarithms and not even using the chain rule at all. So that was an option in that case. Okay, so let's do another example. How about, let's say we've got the derivative of, this time, let's say you have natural log of x, the entire thing all squared. Now notice this one is different from this one because here you're squaring the entire natural log function. So if you look at this guy, this is also a chain rule situation, but this time the outside is the squared and the inside is the natural log of x. So when I'm getting the derivative of this guy, I use the chain rule again. So I would bring the 2 down by the power rule, 2, subtract 1, so this would equal to 1. You can not write it if you want. Leave the inside alone, so natural log of x stays the same, and then times the derivative of the inside. Well, the derivative of natural log of x is just 1 over x. Notice that this one looks different than this one that we just did on top because it's a different function. Okay. How about another one? Let's say we want to find the derivative of, how about something crazy like natural log of x squared times 4x minus 7 to the 4th over 3 raised to the x times e to the x squared. Now, at first glance, I mean, this looks absolutely terrible. Terrible, terrible, terrible. If you look at this guy, I mean, we would have to use the chain rule, of course, but you would have the derivative of natural log of all of this inside is equal to 1 over the inside times the derivative of the inside. Now, when you get the derivative of this inside, you would have to use not only the quotient rule, but the product rule on top, the product rule on bottom. This would be a huge mess. But what if we use instead of doing it directly, if you remember your laws of logarithms, and if you don't remember them, go back and look them up. The ones that tell you how you can break up and put together logarithms, this guy is equal to, I can actually break this guy up in one step. This whole thing, if I break it up, this would break up into 1, 2, 3, 4 logarithms. And so when I break this guy up, this is going to be equal to 2 natural log of x plus 4 natural log of 4x minus 7 minus, let me change that green to a less offensive green, minus x natural log of 3, and then minus x squared times natural log of e. And again, if you don't remember your laws of logarithms, go back and review them. But this is what this guy breaks up into. Now, then what you can do, since this is now just a sums and differences, these you can do each one individually much, much easier. So let's do that and see what we get. So this is going to equal to the derivative of 2 natural log of x, which is simply 2 times, 2 is a constant, remember. The derivative of natural log of x is 1 over x. Okay? And then I've got plus 4 times, now here I'm going to have to use the chain rule, of course, but the derivative of natural log of stuff is 1 over the stuff, 4x minus 7, times the derivative of the inside, which is simply the number 4. So this is going to turn into 16. Okay, and then minus, and then notice that natural log of 3, this is a constant. So really, and just leave the constant alone, and then times the derivative of x, which is just the number 1. Okay, and then minus natural log of e is also a constant. That one is actually just the number 1. And then the derivative of x squared, which is 2x. And so, believe it or not, this, what initially seemed to be a incredibly insane problem, was reduced to a pretty simple situation, if you think about it. Okay, so now the question is, what if we have a logarithm with a different base and I still want to find the derivative? Well, simple. So let's say we've got the derivative of log with a base of b of x. Well, the trick is to use the change of base formula. So since we already know how to find the derivative of natural log, we can change the base of this guy into, instead of derivative of log base b, we would do derivative of so we're going to change the base from b to natural log, so base of e. So this is equal to natural log of x over natural log of b. Now, the b is a constant, so the derivative of this guy is the constant. I'm going to leave it alone. And the derivative of natural log of x is just 1 over x. So this turns out to be the same thing, except that you have an extra natural log of b factor on the bottom. And that's it.